Bismillahirrahmanirrahim. This question we have of June 2016, 33 variant question number 7, and integration by substitution. And we given this correction, this relationship given from examiner to convert this relation to this. So let's see how we can do it. Full question in X form, convert in U form. So first of all, whenever given this substitution, we start differentiation from here. And we'll try to get the value of dx first. So it will come from here. So let's start. Bismillah ar-Rahman ar-Rahim. So job number 1, du over dx, the derivative of 1 becomes 0 and 2x become, x square become 2x. Cross multiply du equal to 2x dx. And but I need to make dx subject. So what is technique? This du over 2x equal to dx. So this will come here. Okay, what is the benefit of this if I will finish, I replace. So let's see what happens then. I have a x5. I can break in two parts, x4 into x, and down part in denominator. This x square, this one, even the full thing, 1 plus x square fully match. So u will go in denominator. So I get u to power 3. In the place of this dx, I will replace it this one. So I get du over 2x. Now you can see that this x and this x will cancel out. And I can do it simply. This x power 4, I can do a little change, x square to power 2. So I can write now here x square power 2. So, or I can write, yeah, it's better to write like this. Okay. And I have du, and down I have a 2u cube. So now if I make it x square subject, I mean this one comes on this side. So I can say here that x square is equals to u minus 1. This value I can replace inside. And ultimately, I get a u minus 1 whole square over 2u cube du. So you can see that this is target is achieved. This is achieved. Only problem left is a limits. And let's see how can do the limits part. And I can use same connection to find out the limits. So I say that if lower limit of x is 0, if I plug in 0 here, so what happens? U is equal to 1 plus 0 square. I get u0. So it means a lower limit here in the place of 0. I'm writing 0, 0, and 0.
Sir, it's 1.
Oh, thank you. Thank you very much. Thank you very much. What happened to me anyway? Thank you very much. So this is a 1. So this is a 1. I write 1, 1, even this also 1. Okay. Now I'll go for the next one. If x value is upper limit is 1. If 1. So 1 I plug in here. 1 square is 1 plus 1. I get 2. So u is equals to 2. So I replace upper limit to 2, and that is proved. So my first target is achieved. I part is over. Let's go for second part. Second part, he's asking us what here? That you have to, if you see the question, exact value of I, it means I have to solve for exact value. So have a look here how we can get the I exact value. Job number 1, I will first expand the bracket in the numerator. First term square minus 2 into first term into second term plus second term square divided by 2u cube. and du here. Okay, in this way, now I gotta u square by 2u cube minus 2u over 2u cube plus 1 by 2u cube. Actually, I simplified and same time split by each value, divide by each value. I got this form. Now I will split it. Splitting how 1 by 2 and 1 by 2 comes out and 1 by u inside. Because u square and cube cancel out, I get 1 by u. Similarly, what about this one? And 2 cancel out, and I get here 1 over u square du. What about this? And 1 to 2 limit. And what about this? 1 by 2, I bring it out. 1 to 2 limit to 1 over u cube du. And I'm close to my answer. Okay, do you know we have a whenever down function, this basic criteria, I write it here, right hand side. When function in denominator, its derivative is available in numerator. But one thing important, what is that? The power of function must be 1. Then this always equals to what? Logarithm of function. But this is applicable only when function power is 1. Here power of function is 1 applicable. Here power function is not 1. Here power function is not 1. So this rule is not applicable in these two conditions. Here I'm not doing anything else because u down, its derivative 1 available up is okay. This rule applicable here. But this one, I will bring it up. I am bound to bring it up. Otherwise, I can't integrate. Even this, I'll bring it up 1 to 2, u to power -3. So now I'm starting integration and every person knows now what is the way to do it. Here I got logarithm of u. 1 to, why it's 5 marks question, that is the logic behind. Increase the power by 1, divide by same, 1 to 2 limit. And same story here. Increase the power by 1 and divide by same. We have this approach. Now simplify before to start. Plug in the limits. Please, some students have seen that they plug in without evaluation. No, you will try, will get a lot of trouble. So minus and minus become plus, and 1 over u goes down in denominator. This make question easier. These two twos are 4 because same level, and I get -1 over 4. If you keep inside, no problem at all, but I make it outside, which make question easier. Repeat again, negative into positive, negative, and 2 to the 4. Now my question is ready to plug in the limits. I plug in first 2 and then minus sign and 1. So logarithm of 2 minus logarithm of 1. Here I plug in 1 over 2 minus 1 over 1. Here I plug in 2, so I got a 1 over 4 plus 1 over 1. Sorry, not plus, minus, sorry. So 1 over 1, because 1 square is 1. And log of 1 is all a person knows that every person knows it's 1. 0, sorry. So I got ln 2 minus 0. Here, if I take LCM, so it's becoming -half. And what about this? Here I'm getting it, this is becoming -3 by 4 into -1 over 4. So I get here negative plus 3 by 16. And this is, I get half ln 2. Okay. And here take LCM. So 8 to 16 out of 8, 3 gone, so 5. So minus 5 over 16. Let me recheck. Let me recheck once again. 8 2 is 16, 8. Yes, this is a final, or you can say this is okay, or you can take LCM, or LCM is going on here 16. So 8, you can bring 1 by 16 like this. So 8 ln 2 minus 5. So both forms are okay. You can write any one form. And I hope so the concept is very, very